Alright, linear programming. So we are going to take a bunch of the different skills that we've been learning and we're going to put them all together in one giant problem. So, let's read through it. The available parking area of a parking lot is 600 square meters. A bus requires 30 square meters of space, and a car requires 6 square meters of space. The attendant can handle no more than 60 vehicles. If a bus is charged $8 to park and a car is charged $3, how many of each should the attendant accept to maximize? So, first thing we need to do is create these linear inequalities. They're not going to be equations, they're going to be inequalities. And since they're linear, we know that there's going to be two variables, x and y. So you got to look at which two things you are comparing. In this case, it is the buses and the cars. We have a bunch of information about the bus and then a bunch of information about the cars. Okay, and then you're going to have total numbers that go with them as well. So this is the breakdown of our paragraph here. So 600 square meters is a total. That is the maximum available parking area. So it has to, the buses and cars need to be less than or equal to it. The bus requires 30 square meters and the car requires 6 square meters. So those go into one line. The attendant can handle no more than 60 vehicles, so 60 is a maximum again, but we don't have any specific information about a bus or a car with that. And then the bus is $8, excuse me, whew, and a car is $3. So after this, we're going to throw x and y in here. Alright, so I just created buses are x and cars are y, lined them up nicely. From here, we need to graph these. We need to look at real-world restrictions. So because buses are our x's, you can't have a negative amount of buses. You have to have it at least 0 or more, and same with y. Cars, you can have 0 or higher, but you cannot have negative. So a lot of times those are going to come into play. Just kind of keep those in mind. It's slightly obvious from the graph that we have here. So we need to solve these for y. Subtract 30x from both sides and divide by 6 should give you this lovely equation here. And then subtracting x over should give you this lovely equation here. So I color-coded everything for you. So our blue line is here. Our y values have to be less, so we're going to shade below. Our orange line here, we're also going less, so we're going below. And our x values have to be higher than the red. Y values have to be higher than the purple. So the section that we are looking at looks like this guy right here. That is where all the inequalities cross each other. Okay? So now we've got to maximize this income. So we've got to find the points where these meet. So let's just kind of plop them on here real quick to see. So we've got 1, 2, 3, hold up, let me do this, and then they'll actually show up. 1, 2, 3, and 4 points of intersection here. So we need to find the coordinates of those points. Hopefully at least 3 of them are very, very obvious. If you graphed really carefully, this one will be obvious. If not, you are going to need to solve this system of inequalities rather, but you can treat them like equations to figure out where they cross each other. So our 4 points are at 0, 60, 20, 0, 0, 0, and then the other one ends up being 10, 50. And we'll look at that a little bit more. It does not matter which order you put them in here, okay? And they are going to have to do with the money, okay? We didn't have any sort of inequality here. There was no total involved, so that should be your clue that this is going to be the maximization equation, okay? And let me sneak over a little bit so you can see it. So here, and we already did this part, if you recall, so we're just going to substitute these values in for x and y, and because we are looking to maximize, we are going to see which gives us the highest output. So, get this out of the way. We've got 8 times 0 plus 6 times 30, 8 times 20 plus 3 times 0, 8 times 0 plus 3 times 0, that should not do too much, and 8 times 10 plus 30 times 50. So, we get a whopping $180, $160, $0, and $230 that the attendant can make. And of course, maximizing that, we are looking at $230. So this 1050 is your answer. So your final answer is this guy. The attendant should let in 10 buses, because X stood for buses, and 50 cars, because Y stood for cars, to maximize the income.